find the current in the circuit branches in the figure below, where you have all the resistance and you have two voltage sources, V1 and V2. Ah, that's why, V1 and V2, okay. We need to find current through all those resistors, current through this, through this, through this, and through this, through this. All in all, we need to find the 6 currents. Okay. But before we start, first we're gonna calculate what is equivalent resistance for those 3 resistance, and we're going to replace them all for the start. Of course we will replace them all by the RE, equivalent resistance, and it's calculated is RE1 through it. RE is 1 to R5 plus 2 R4 plus 1 to R6. You have here I did some calculation about it, and we get 21 divided by 17 ohms. That equivalent resistance is 21 divided by 17 ohms. That is little over 1. Now, how we find the current in the branches? First, we will assume this all, again, this all here for time being, we will just treat it as some RE, some equivalent resistance. We will assume that there is one E1 current in this direction, clockwise, and E2 current in this direction, clockwise again, and current E3 again in the clockwise direction. We will write something here. V is equal resistance time current. So voltage is equal to resistance time current, just to have some guidelines. So for this first contour, here this is first contour, second contour, and third contour. For this first contour, we will write as simple as this. First contour. So V1 is equal, that is voltage, R1 times E1. This is this current and that resistance. Okay. Then we write plus. Then write plus what? E1 RE. RE times E1. Then minus what? Minus R1 E2. Minus R1 E2. Why is there a minus? Why? Because this current is going in this direction and this current is going in this direction. So let's say they are in some kind of a conflict. This voltage here likes to push the currents in this direction, the clockwise direction. So this will be plus, and this will be denoted as minus, and so on and so forth. Okay, that is the first contour. Second contour. Second contour, I will start by V2 is equal what? Again, R1 E2. R1 E2 plus R2 E2. This is one E2 current and one resistance. E2 current, R2 resistance. Okay, but there is a minus. Minus what? R1 E1 and minus R2 E3. That is this current here. But with one small difference, here is minus V2. Minus V2. Why is minus? Because this is opposite than clockwise. This is a positive pole of the source, a negative pole of the source. Here's positive, here's negative. The positive pole of the source, he likes to push current in this direction. But as we see, it is opposite to this current. So we denote it here as minus. Now for the third contour, there is no voltage source, so we write 0. Here is 0 is equal to what? is equal to R2 E3 plus R3 E3, that is this current in this direction throughout this resistance is this one, and throughout this resistance is this one, but we have minus here, minus in this contour. This situation is counterclockwise. E2 current is for this current E2 is counterclockwise, minus R2 E3. Now we replace voltages and resistance and so on and so forth, and we will have three equations with three unknown magnitudes. Here is what I wrote. Again, you will find it written, of course. Generally, that holds. V1 is equal. This is for the first contour. This is for this contour. Just bear in mind that this I replace this with equivalent resistance. Okay. And then I replaced everything that I have because it's easier to calculate this way. So I divided with ohms here, voltage divided by ohm is ampere. So this is the first equation derived from the first contour. First equation derives from first contour, that the first current, second current, that clockwise current that we assume that they exist there. So this is from the second contour, rewritten of course, and calculated. This is the relation between the currents in second contour. And this is from the third contour, and this is what we have at the end. This is the third equation. First equation from first contour, second from second contour, the third from third contour. And we have three unknown quantities, E1, E2, and E3. So we just substitute. We have three unknown quantities and three equations, so we solve that. From through the equation, we have the relation between E3 and E2, that E3 is exactly half of E2. Now put that in second equation. So we fiddle with it, sort it, and we find the first current. Then we return in the previous second current and third current. That is three equations and three unknown magnitudes, so it's not difficult to calculate that. So then we have all of these three currents. We find it, we calculate all of those three currents, so we have some answers. Currents that pass through resistance is actually this one, this current, E3, and that is what we find out there. E3 to be E3 is 1.33 amperes. We find it to be 1.33 amperes. 1.33 amperes. That is this current. Now, current throughout second resistance, ER2. ER2. What is the current throughout this resistance? This is the E2 minus E3. That is the current throughout that resistance, and I remembered from 2.66 amperes minus 1.33 amperes, that is 1.33 amperes. Current throughout this resistance is this big. Current to this resistance is this big. Current throughout resistance number 1, ER1, is equal what? That is E1 minus E2. Magnitudes are important here, so you place first that is bigger. First one was 7.83 amperes. 7.83 amperes minus E2, that is our clockwise current in this contour, that was 2.66 amperes. 0.66 amperes, and that is 7.83 minus 2.66, 5.17. 5.17 amperes. Now we find current throughout this. Now we find current throughout this resistance, through this, and through this. Okay, now we have three more, but those three are a little bit different. So we're going to see what's happening there. First of all, we need to find voltage between those 2 points. We don't know that, we need that. Voltage between those 2 points. And that will be, just to see, I don't know. Let's say U is equal RA times E. But that E is actually E1. We have this, we calculated before, E1, we have that also, that is 2.66. So we find the voltage between those points very easy. And then it's not too difficult to find this, this, and this. That you have that written downwards. But for complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Bye.